Hey guys, welcome to Wednesday, May 6th. We're going to go ahead and move into section 3, which is, as you can see by the top of my screen here, confidence intervals for proportions. These are pretty straightforward. We're still doing confidence intervals. The formulas are very similar. For some reason, students get a little bit confused with these, but it's not bad at all. You notice that P is our population proportion and P hat is the proportion of our sample. You'll need to keep those straight. I see that students have a little bit of difficulty doing that on occasion, but it's not that bad. P hat is just simply the number of successes divided by n, where n is the number of trials. And Q hat is just simply, as always, 1 minus P hat. The thing about this, remember the last video I showed you that there are 3 conditions that have to be met. The first condition is random. The second condition is independence, and the third condition is normality. And the difference with the population, with proportion, normality, I'll go over with you when we get to it. So let's go ahead and clear off this screen and talk a little bit about what's next. Okay, so some important formulas that you need to know. These are on your blue sheet. They're just a little bit different on your blue sheet, but these are what you need to know. In order to find the confidence interval, all you do is you take P hat, the sample proportion, plus or minus, notice Z of alpha over 2, not T, Z. Whenever you do a proportion, all proportions are Z scores, not T scores. The only time you use T scores is if you do not know the population standard deviation, okay? And then you're going to multiply that by P hat, Q hat, and we already know what P hat and Q hat are, and O divided by N. If you want to know the sample size that you need, to find N, you take P hat times Q hat, and you multiply that by Z of alpha over the quantity of Z of alpha over 2 divided by E squared. So let's do an example. I'll go ahead and read our example problem here, and then we'll do it. A sample of 300 students, 66 of which said math was their best subject, with 95% confidence, what percent of the population find math to be their best subject? Okay, so first off, what we're going to need to find is we're going to need to find P hat. Now, P hat's not that bad, okay? It's just simply the number of successful trials, which is 66, out of the total number of people asked, which is 300. Okay? Now, of course, we can reduce that a little bit. Okay. And if we reduce that a little bit, we get 0.22. Okay? Which makes Q hat also very easy to find. 1 minus 0.22, which equals 0.78. Now, the rest of this should be easy. We found P hat, we know Q hat, we know N. The only thing that we're missing is Z of alpha over 2. So let's go ahead and find our Z of alpha over 2. Well, what do we need? We have a 95% confidence interval, which means that we are looking for, on our Z table, we're looking for 0.025. But let me show you something that makes your life a little bit easier. Take a look at your T chart and go all the way down to infinite degrees of freedom and go over to your 95%. Look up one spot. What do you find? You see 1.960. Guys, you can certainly use your T chart to find your Z scores, especially if you know your confidence level. It'll make your life a lot easier. But it's always going to be an infinite number of degrees of freedom because we don't worry about degrees of freedom on these proportions. So our z-score is going to be 1.960. And notice this is one more decimal accurate than what you have on your z-table. Okay, so what do? Well, we find our answer. Okay, so we need our 0.22 plus or minus the 1.96 okay, and we need the square root of p hat, which is 0.22, times q hat, which is 0.78, all divided by n, which in this case was 300. Now, we're still going to have our 0.22, and here's a sticking point where a lot of you have a difficulty in figuring out how many decimal places. I'm going to make it easy for you. When you're dealing with a proportion, always, always, always 3 decimal places. 3 decimal places. No more, no less. So if you take 1.96 times the square root of this fun stuff, you're going to end up with, into 3 decimal places, 0.047. Again, always 3 decimal places. Okay, so what do? Well, what's 0.22 plus 0.047? Well, that's 0.267. And 0.22 minus 0.047 is 0.173. Now notice that when I write my inequality to show, or my interval, notice that instead of mu, I am now writing p because I'm dealing with a proportion. Okay, and what do I still need to write? I still need to write my confidence statement. Okay, so I am 95% confident that the true proportion of students who claim math as their best subject clearly mine isn't handwriting is in my interval. Okay. All right. That was just a quick example problem to give you an idea of how do you work the formula and everything like that. The one thing that I did not do that you will be doing, and what we'll be doing on our later example problems, is our conditions. Okay, because still, some people still have a difficulty with conditions with proportions. So I'll definitely show you some of those. Okay. Okay, so for this next example, the question doesn't make a lot of sense, but I wanted to show you how to use the sample size formula, and there's some special occasions where you have to come up with something. So we're asking for a sample size of something. We're not quite sure what, but we want a 90% confidence interval, and we want to be within 3%. So we want to know the number of people that we actually have to poll in order to find whatever it is we're trying to find. Okay, so one of the things that you notice is there's no proportion here. Okay, if there's no proportion, okay, and we're dealing with a proportion, which we are in this case, you're going to use, so I'm going to write this down, if no proportion given, use p hat equal 0.5. That means it's a 50-50 chance. Okay, so basically, if you're going to poll someone, if they're a Democrat or a Republican, there's a 50-50 chance there. But either way, if no proportion is given in a problem, use p hat equals 0.5. So what does n equal? Well, n, again, remember, is p hat times q hat, so it's 0.5 times 0.5. And then in this case, z of alpha over 2, if you use your handy-dandy or t table at 90%, you find that you get 1.645. So we're going to put 1.645 here over 0.03, and we're going to square it. Okay, when we do the math, we get n equals 751.7. Okay, now remember, guys, if you're polling things, you can't poll 0.7 of a person. If you see 0.7 of a person walking around, run, because the zombie apocalypse has come, and they've been eaten. So we need to round this up to 752. So we would need to poll 752 people, assuming that we aren't given a proportion of something, in order to find the number that to be 90% confident and within a 3% error that we have the number that we want. Okay. What do you think would happen if we changed a couple things on this problem? What if we changed the confidence interval to 99% and we want to be within 2%? What's going to change here? Well, the 0.5 times 0.5 is not going to change. But this 1.645 that we had, that's now going to change to 2.576. And that 0.03, that 2%, is 0.02. By the way, guys, when you change a percent to a decimal, make sure you put that 0 in there, because a lot of people forget that and they make it 0.2 and things become much worse. Okay, let's see how this changes the number. So we're going to take our 2.576, we're going to divide it by 0.02. We're going to take that number and we're going to square it. And then 0.5 times 0.5 is still 0.25, so we'll multiply it by 0.25. And in this case, because we want to be more accurate, both with our confidence interval and within our certain range, we want to be closer, we have a number of 4,147.4 people. Or, now again, we need at least this much. Even though this 0.4 says that you would normally round down, if there's anything here, we have to round up. So we need 4,148 people. So by becoming more confident and having less room for error, we all of a sudden need, we went from 752 to 4,148 people that we needed to survey. So does how confident do you want to be make a difference? Yes. Does the error that you want make a difference? Yes. Okay. Let's do a couple of problems fully now. I'm going to pause again and write the problem. All right, so here's our problem. A random survey of 200 workers found 168 that said they were interrupted 3 or more times an hour by texts. Find a 90% confidence interval of the population proportion of workers who are interrupted 3 or more times per hour. First thing we need to do is we need to start with our conditions. Okay, so remember what our 3 conditions are. First condition, SRS. Okay, is it random? Well, yes, it says so right here, a random survey. So that is given. We don't have to assume it. Okay. Is it independent? What's the check for independence here? Is the population greater than 10n? Well, n is 200. Is there more than 2,000 workers in the world? Yes, so this would be independent. Okay. Now here's the different one, the check for normality. Remember what we said, when you're checking for normality here, we have to have n times p has to be greater than or equal to 5, and n times q has to be greater than or equal to 5. Now, guys, don't get confused here. The P here is actually the population. So what all this is basically, you have 168. You know that there's 168. Now, if we were given a percentage, then you might have to do a little bit more work. But, is 168 greater than 5? Yes. Is 32, which would be Q, greater than or equal to 5? Yes. So are we good as far as our check for normality? Yes. Okay. So now we got to do the problem. Well, the problem is pretty straightforward. What is P hat? P hat is 168 over 20. I'm sorry, 200. Plus or minus Z of alpha over 2. Well, we've got 90%. What was our 90% number? It was 1.645. And we take that and multiply it by P hat Q hat over N. P hat, 168 over 200 as a decimal is 0.84. Which makes Q hat 0.16. And we divide that by 200. So we get 0.840, because remember, 3 decimal places, plus or minus, all this multiplied to 3 decimal places is 0.043, which gives us 0.797 is less than P, notice not mu, P, which is less than 0.883. So everything's pretty much the same. What would my confidence statement be? I don't have enough room to write it, and I'm not going to write it on another page. So basically it's, I am 90% confident the true proportion of workers interrupted is contained in my interval. So somewhere between 79.7% and 88.3% of our workers are actually interrupted. All right, last problem for today, because I don't want to take forever with your video. I want to give you all a little bit of time just to watch it, and then we'll do as usual, practice it tomorrow. Okay, so we have a medical researcher that wishes to determine the percentage of females who take, vitamins. He wishes to be 99% confident that the estimate is within 2 percentage points of the true population. A recent study of 180 females estimated it to be 25%. How large should the estimate be? And then B, if the recent study was unavailable, how large should this sample be? Okay, so we're looking for estimate sizes or sample sizes, right? So we need to look at N. Okay, so what are we going to do? For part A, we've got our formula N equals P hat Q hat times Z of alpha over 2 divided by E squared. Okay, since we had that estimate of the error of what it was, they said it was 25%, so that means P hat would be 0.25. Okay, so Q hat would have to be what? 0.75. What are you noticing that you don't have to do right now? I'm hoping that you're noticing that you don't have to do your conditions or anything like that. Okay? Whenever you are doing something where you're looking for a sample size, when you're trying to find the sample size, you do not have to go through the conditions. Okay? Just a nice little thing for you. The Z of alpha over 2 from your blue sheet, from the T table all the way down at the bottom with infinite degrees of freedom is 2.576. And we're going to divide that by our error. Our error was 2%, so that's 0.02. And we need to square that. All right, so that means that we have, if we do our math correctly, 3,110.52 people. Again, you can't survey a certain, you have to survey at least this many. You can't survey 0.52 of a person, so that's 3,111. Okay, please don't ever round down. Okay, and that's it. That's that part of the problem. Now, what if that original survey wasn't available? What changes? Well, this part does not change. That's still the same. What does change is the 0.25 and the 0.75, because we don't have that estimate. So what do we use? If it's not, again, and students have a hard time remembering this for some reason, if you don't have an estimate, use 50-50. Okay? So N equals 0.5 times 0.5 times all of this. Okay? So when we do our math, we get 4,147.36. And again, please do not round down. So you need to do at least 4,148 people. That's how many people you need to survey. All right, guys. That's our video for today. For those of you seniors that took part in the video that you sent to the teachers, I really appreciate that. It was a really nice touch. Thank you so much. And if you didn't, that's okay too. I still appreciate my seniors in this class. You guys have a great day. Try to smile. Try to laugh. And if you smile and laugh, what was it that Jim Valvano said? If you smile and you can laugh, you've had a full day.